Welcome to Module 2 of Yellow Belt Training. We finished the Fundamentals module. As I mentioned before, the Fundamentals module was a rather intensive downloading of the body of knowledge. So we covered pretty much the entire body of knowledge in that one module, which may be a lot to absorb. Now we're going to break it down phase by phase and repeat some of the key information, particularly with respect to Yellow Belt, in another view of it in a slightly different context. So this module covers the define phase.
I'm a certified Six Sigma Black Belt with the American Society of Quality, and I'll be conducting your training.
Going over the concept of customer. The concept of customer is very important to Lean Six Sigma. There are external customers, such as the ultimate customer who purchases your product. There are your internal customers, also often referred to as stakeholders. They're the people within your company that receive process output of each of the processes in the system that makes up all the processes to make your product to deliver to an external customer. And stakeholders are the people, departments, and groups that have an investment or interest in the success or actions of a product, or what might happen to of a project, or what might happen to a product that's being improved. A distinction can be made between customer and stakeholder. They're somewhat synonymous. But stakeholders do not receive the product or service, but have a vested interest in how the process performs. So stakeholders may not have a direct interest in the changes to the process or product, but they certainly have a vested interest in it. They don't receive it, but they have a vested interest in it. Generally, customers and stakeholders are somewhat synonymous. And customers, again, can be external or internal, and a customer does not have to be literally a person. A customer is anything that receives output from a process or a system of processes. It can even be a next process step can be a customer of the previous process step. So the concept of voice of the customer is an important one in Lean Six Sigma. The voice of the customer is more of a concept than it is a tool, although there are certain tools we use to help us with voice of the customer. It's a term that describes how your customer's needs from their perspective. What is their perception of quality? What's important to them? What do they believe adds value? And again, this could be internal, external, or it could be a process step as a customer of a previous process step. The recipient of the output needs to be the one to define what's needed and what is quality. And you have voice of stakeholder analysis is analogous to voice of the customer. What do we do to make sure that everyone who has a vested interest in the process, those who directly receive it, or those who have an interest in making sure that those who do receive it, to their satisfaction, we can do analysis, and that's stakeholders analysis. Voice of the customer is an essential element of any project. You need to identify your customers and stakeholders, who are internal and external customers. What's their demographics? Where are they? What's their age? What's the characteristics of the customers, their industry type? Customer feedback requires selecting the best procedure for collecting customer data. It should be random, reasonable, rational, and large enough for a representation, complete and accurate. Customer feedback requires selecting the best procedure for collecting customer data. Written surveys, focus groups, interviews by phone or in person, warranty data, including documented complaints, problem logs, all sources of customer feedback. It should be objective and give light to the requirements of the customer. And several independent sources can show contradictions, patterns, or reinforcement of conclusions. Voice of the customer requires an understanding critical to quality. Voice of the customer is what's important to the customer in their language, and that has to be translated into critical to quality characteristics that can be measured. They're the dependent variables, or the whys, that are a function of the voice of the process, or the input that is independent of the critical to quality that drives it. Critical to satisfaction is the catch-all term for critical to quality. Critical to satisfaction covers critical to quality characteristics that really could be formally associated with defects. And then you can also have critical to delivery and critical to cost. So there we see the major project elements of functionality, time, and cost. They usually get all lumped under CTQ. So normally when people talk about critical to quality, they've implicitly put in there critical delivery and critical to cost in there, although they can be broken out separately. Usually a process improvement involves elements of improving quality or accuracy or precision or effectiveness, and elements of improving time. And all this has to be done under a cost-conscious environment. Critical to process are, again, the independent factors, and they're the voice of the process. Some factors are more critical than others, are the constraining factors that really drive the dependent variable y, and those are the ones we seek to find and control and correct in the DMAIC method. Here we have an example of a representation of critical to quality flow down, or a flow down tree. They can take various forms. The important point of this is you start with strategic goals. So you have to always align what you're trying to do with the voice of the business. And you have project objectives that are going to improve value in the customer's eyes, or the voice of the customer. We convert those to critical to quality requirements, which are a measurable interpretation of the voice of the customer, where they articulate problems in their own language. And we take this down and we look at the system level, and then we can break the system into sub-processes that we can attack and find the constraining processes that limit our ability to satisfy the customer. And then once we target specific scope of sub-process, we identify those voice of the process, or those X elements that drive it, and we improve the critical to quality. And we do this across the process levels that form a system. Here's another form of CTQ flow down. Strategic goals, increase sales, customer satisfaction is the voice of the customer. We have project objectives, and then we have critical to quality. Light requirements, what are soil requirements, what are care requirements, and then what are the factors that go to each of these dependent factors that will be improved to the maximum extent possible with respect to value in the eyes of the customer. So this is a visual flow down representation. They can take many forms. This is a typical way of showing visually voice of the customer. Many times a voice of the customer or stakeholder analysis can simply be put into a table, and this is a classic form of voice of the customer. You have who your customer is, who the stakeholder is, and then you put what's important to them in their language. And then you try to start to identify what their key issues or concerns are, and then you try to begin the process of putting it down into requirements. A table is oftentimes sufficient for voice of the customer, summarizing the analysis of voice of the customer. You certainly become more sophisticated, and one tool that is often used for voice of the customer analysis is quality function deployment matrix, also known as the house of quality. It can get quite complex. The heart and soul of it are the green boxes there, 1, 2, and 3, which is simply an XY matrix that we've already covered. So many times when people do a QFD, they'll only use those 3 boxes, 1, 2, and 3, and they'll call it a QFD. And when you look at it, all you'll see is an XY matrix. So the pink boxes are often eliminated. Here we see an example of a house quality of QFD, and you can see there in the center is the XY matrix. You notice that the rows are weighted, they're your dependent variables, and then you have your X variables, your independent variables, or your factors that drive the critical to quality requirements in your rows. So the heart and soul of it again is an XY matrix. Here we see an XY matrix voice of the customer broken out of the house quality, and typically this, if you're going to use more than a tabular voice of the customer and you're going to want to put some numbers to it to help you rank it, you simply use an XY matrix like this. Or you can use various forms of tables that do not use numbers, such as this is an example of stakeholder analysis, where you have a target level necessary and you show visually a current level to give people an idea of where we need to improve in the eyes of the customer. Now, we're not going to cover these here in great detail because they're covered in measure. But CSSYB there that you see on the left in the table, Pareto and high-level process maps are very important voice of the customer tools. They help you identify what's important to the customer and where that it's being affected in the processes. So keep these in mind when we go over them and measure that they can also be used and are often used, not always used, in define phase for voice of the customer, particularly a CSSYB. With all tools and concepts in Lean Six Sigma, remember to remain fluid and where you conceptually try to place these tools. The DMAIC process is a continuum. It does not necessarily flow sequentially, and you use many tools in many different forms in interrelated ways throughout the DMAIC process. Here we have a Kano model. You can study this at your leisure. It's important for you to at least know about it. The philosophy embodied in this tool is that the object is to delight the customer. However, over time, the customer is desensitized or becomes bored with those things that used to excite them, so that you have basic features, fulfill them on a basic level, and if you want to delight the customer, you have to continue to innovate over time. So let's summarize the voice of the customer. It's anything that helps you identify what to improve from the viewpoint of the customer, which is the only value-added viewpoint. It's a key term in Six Sigma. The concept of focus on the customer, because that's the only way you can know what value is core and fundamental to all of Lean Six Sigma. Pareto analysis are important, so you can see where you are with respect to those items that are displeasing the customer, and getting a visual representation of those vital factors. You get proposals from customers, you get field studies, data on performance competitors, data from users, comments of key people, findings from auditors and government, customer suppliers, brainstorming by stakeholders. This is just a additional list of ways we get voice of the customer. It's important to understand that it can really be a never-ending list of ways to understand the customer, but the concept is, what does the recipient of the output need and believe is valuable? Obviously, it's important in the define phase that the project is properly selected. Champions and master black belts should follow a structured method for identifying, prioritizing, and selecting projects. They need to understand the strategic plan. What are the key business goals and objectives? What is the organization trying to do? Then these projects need to, all improvement projects need to align with the strategic plan. You have to understand how the project aligns with the strategic plan and is likely to work under the present deployment methodology of the organization, under its present policies and constraints, under its executive protocol, under its culture, so that you give the project the best chance of succeeding. You need to define projects with people who understand the business processes and the core business processes so they can be targeted appropriately. You can identify the proper gaps between where you are now or where you want to be, and then what are the targets that are appropriate given your present state and your culture. And all these go into project selection. Now, we covered project selection quite a bit in fundamentals. And I referred to you to this one-page visual of project selection. When you to review project selection, you can go back to fundamentals and look at the roles and responsibilities and how prospects are get put into a hopper or funnel and selected in alignment with the business plan and the reasonable objectives of your culture to come out to projects that are executed. As we talk about defining a project, we're going to cover basic processes here. It's important to understand that Lean Six Sigma works on an improvement approach that is process-based improvement. Processes start as the basic process step where you have inputs and they give an output. Processes link together to form sub-processes and then work up to major processes, which you could call a system. So improvement focuses on processes in Lean Six Sigma. It's process improvement. One of the key tools for identifying a process, particularly in the define phase, that will also help you develop a voice of the customer, is a high-level process map called a CSSYB, suppliers inputs, process outputs, customers. It helps define project boundaries. It defines suppliers and customers and stakeholders. It helps you define key inputs and outputs, X's and Y's, and it helps to support process thinking in your. Here we have a CSSYB. It's supplier input, process output, customer, and optionally you can put what's critical to quality for that particular process step out there in the last column. That is an optional column that you don't often see. When you develop a CSSYB, which is basically a high-level process map, the first thing you want to do is, of course, fill out a title. And it can be surprisingly difficult sometimes to get a consensus on the team with the title of something, but that is important because it represents a common, what you're naming can represent, how you name it can represent whether there's a general understanding of what you're trying to do. So you give it a title, put your process steps down there first. On a CSSYB, usually about 6 to 8 steps. Usually that would be a maximum of 8 process steps. This is a high-level map. And after you have your process, you put your inputs and outputs to each process step, then your supplier and your customer. Now usually it goes in a zigzag pattern where the customer of one process step is the supplier to the next process step, and so on. It does not have to always be that the customer from the previous step is the supplier in the next, but that often is the case. So this is a typical CSSYB. You usually could expect that most all of your projects at some point will have a CSSYB developed. Now the project charter is a key define phase document. It's also called many times a business case, or often you have a business case that turns into a project charter. And it serves as a contract that helps teams stay on track. It's a contract with the champion and the organization. These are the elements that in some form or another, whether explicit or implicit, really should be in a project charter, hopefully explicitly. You need a problem statement that gives a clear description of the problem, not necessarily too long, about a paragraph. It gives a clear description of the problem. The problem statement must be in measurable terms. You must be measuring a critical to quality or Y in some measurable way. Rate or defect rate, counts of defects, cycle time, cost are all measurable CTQs that should be in the problem statement. Usually some form of defects or quality or some form of cycle time is the measurable problem statement, critical to quality. You need a description of your goal. Your goal or your target should be in the same measurable terms as used in the problem statement. That's your gap. So if your goal is to reduce cycle time to some value, your problem statement should be that your cycle time is too high. You can take your gap and your improvement and calculate a business benefit. The universal language of business is dollars. You try to convert all benefit into dollars. It's the common denominator. So when you save time or reduce defects, you should convert that to benefit in terms of dollars. Charters should clearly define the project boundaries, and you should have a project scope. Usually projects, by human nature, almost universal shortfall of projects or pitfall of projects is that they're overscoped. It's difficult to have too small a scope. When in doubt, scope down. The tendency is usually in the first stage of a defined project, when you're defining it, is to scope too big. Your team has to be clearly defined. You need to have a champion. You need to have team members. In Lean Six Sigma, often you'll have a black belt, subject matter experts, and it's critical to have a process owner on your team or somebody who represents the process owner. You may have a team leader in addition to the black belt and others relevant to the project, but in your charter they need to be identified. You should have a plan with milestones. What are the work breakdown structure for your project? What are your key project steps, and what is your estimated date to complete them? This is a universal ingredient of a charter. It's my recommendation that you have all these 6 elements in a project plan, whether it's Lean or Six Sigma, explicitly as possible. You have an immediate red flag that is going to cause you problems. If your problem statement is not in measurable terms, you know you don't have it very well defined yet. And another pitfall is that your team doesn't really contain a process owner or a representative of the process owner. We'll go over some of the elements in a little more detail. And the problem statement needs to be agreed to by the sponsor and champion and process owner. It should be a concise statement of the current state. Problem statement should not assign blame, imply cause, or suggest solutions. That's an important point there. Those 3 things, blame, cause, or solution, should not be in your problem statement. It must be in measurable terms that is observable, manageable, and specific. And here's some examples of short problem statements where you have some measurable current state and a statement of that current state in measurable terms. Now, the goal defines a gap or level of improvement the team is seeking. Improvement starts with a questioning attitude. You question the status quo. You are not satisfied with you don't believe that you're at a current state that is good enough. That's called a questioning attitude. And you believe there's a gap from where you are to where you should be. And then the problem statement defines that gap in measurable. The goal defines that gap in measurable terms. So you should have an objective. You've stated your current state and its cost in your problem statement, and now you're going to identify a target or a gap to where you want to be. And the goal should be in the same terms as the problem statement. It should be measurable, achievable, and you should have a time frame for achieving that goal. Here we have some example goal statements. We're going to improve the present yield from 60 to 90 in 6 months, and so on. Generally speaking, all processes can be measured in terms of quality or effective, that is effectiveness or defects, and cycle time. These are the two basic types of metrics. Generally, you hold one as a primary metric and one as they come in various forms, but you hold either quality as your primary metric or time as your secondary metric or vice versa, and you focus on improving the primary without compromising the secondary, and you can target improving quality or reducing time as appropriate. Reducing costs without focusing on improving quality or reducing cycle times, cost cutting. You can save costs in the short term, but it's suboptimal. The best way to reduce costs is to improve your effectiveness, improve your efficiency. Benefit is based on the best available data and assumptions in the defined statement, and it's updated as the project progresses. Financial dollars is the common language of benefit. You can have soft benefit, which doesn't immediately convert to hard dollars, or you can have hard dollar bottom line savings, such as reduction of scrap. Cycle time, for example, is more soft in that as you free people's time up, you really receive the benefit when you reallocate those resources. It's good to review benefit with financial experts. Usually a team may have often a team may have, it's recommended that a team have a subject matter expert who is an accountant, who, as they go through the project, will help them develop strategies for converting their improvements into dollar terms. You can have various types of worksheets for cost of poor quality. This is one that came out of a statistical analysis software, QI macros. You can make your own tables, but you can go through and you can look at all your savings and estimate what benefits you have from it, your payback periods. You can use return on investment, net present value. You can go from simple estimates of the benefits all the way up to having an accounting or finance person help you with sophisticated calculations of the return on it, reducing cost of poor quality. It's important that you have a sum acceptable to your stakeholders representation of the benefit of your project. The level of sophistication will depend on the requirements of your stakeholders, but you should always state some kind of benefit and make an estimate of it, hopefully in terms of dollars. Scope is always in the charter again. You should have manageable boundaries. It should be in something that the team is capable of changing. You don't want too broad a scope. It's hard to scope too low. You want to be able to find a scope that allows you to find root causes to an area of a process that is within a manageable boundaries of the team and organization to improve. Oftentimes, a good scope statement will really state what is not in scope, and this is very useful. Several tools to help you define scope are Pareto charts, where you're showing why you're attacking certain factors and not attacking others, and you can demonstrate that they're the vital factors in a Pareto chart. Cause and effect analysis, fishbone diagrams, affinity diagrams, which are diagrams that group alike causes together. where you can show that a group of causes seems to be a predominant factor, and process maps, all good for identifying scope. And the charter should contain the project team. Again, you need a process owner on the team, or you're going to be in trouble, or somebody that represents the process owner. Otherwise, you're working on a process that you don't know if the person who owns it is going to give you the time of day or not. So you're cooked if you don't have a process owner on your team. You should have a champion, and that should be on the team. It should be clear who the champion is, who the process owner are, and who the team members are. Usually team members for any kind of problem of significance will be multidisciplinary. And you should show on the charter the estimated amount of time each team member is going to be expected to contribute. Usually projects, whether they're Lean or Six Sigma, that are either rapid improvement events, which are 4-day workshops, so you have the pre-time and the post-time in addition to the 2 or 3 days of the workshop, or they're a project, a Lean or Six Sigma project. Typical projects are 3 to 6 months, where you meet 2 or 4 times a month for a couple of hours, and then there's outside effort on the team. So you should kind of lay out the resource expectations. You should identify any subject matter experts who are going to be important to the project. Subject matter experts are not expected to come to every team. The team members are expected to come to every meeting. Subject matter experts are part of the project, but they're on an on-call ad hoc basis. Now, every charter should have an outline of the project plan with milestones. One of the favored methods is Gantt charts, but you can also have PERT charts or tables of schedule, but you should really show what the plan is with respect to schedule and timing on your project. With that, we'll cover Gantt charts, which are a good way to outline project milestones and schedule. You have a work breakdown structure identified in your task, all the tasks necessary to achieve the success of the project, or at least those that are key enough that you would want to list them. Each task in the work breakdown structure should have a resource and a time duration that it takes. It's an excellent way to give a visual listing of the work breakdown structure, what tasks can proceed in parallel, what tasks need to be sequential, so you can develop your lead and lag times. You can identify a critical path, those activities that take the longest and limit the throughput of the project. So you control the project being on time by controlling the critical path. PERT charts, which is project evaluation and review technique, is also popular by some project managers. Here each activity in a project, you list the earliest start time, earliest finish time, earliest start time, and latest finish time, and you can compute a slack time or a buffer. You can compute then the critical path, or the earliest, but the least time it could take to finish the project. And we see here in this example, it's path B, D, F, G, and H, leading to a 55-day minimum project time. Under project management tools, we're covering affinity diagrams. This also could have been covered under brainstorming. It's used to produce, organize numerous possible answers to a question. It allows a team to generate a large number of ideas and then organize them. So you want to clearly phrase the issue under discussion and brainstorm. You can capture the notes on index cards or sticky notes, and then you can group them into related groups, which is called affinitize. So how do we produce more widgets on line A? And everybody would throw out their ideas, and then you group them, and you can start to decide which ideas you're going to further investigate. Another project management tool is interrelationship diagrams or relations charts. It's good when a team wants to understand relationship between issues, helps hone in on root causes for potential root causes for collection of data. You develop the problem statements, and you list the issues related to a problem on a card or post-its, and arrange them in a circle, and identify cause and effect relationships as being strong, weak, or none. Draw arrows to indicate the direction of influence for each relationship pair. You can draw a dotted line to represent a weaker relationship, as we'll see in the following example. And then you'll find that drivers are the possible root causes, or those issues that have the most outgoing arrows, and they're the most important issues. So here we see a relationship diagram on why do people not use DMAIC problem solving. And we see that this analysis would imply that the DMAIC process is not understood. So understanding is the driver for people not using the DMAIC problem solving. If they understood it and how wonderful it was, everybody would use it, is some of the implication of this relationship chart or diagram. A tree diagram is another way to explore cause and effect. It's used to break down broad categories into finer and finer levels of detail. When used to study defects, it's called a fault tree, and it may have actual probabilities associated with the independent factors that are causing the effect. You develop a statement of the goal or the reject or the problem or the issue, and then you write it on top of the vertical tree, and you begin to dig down or drill down level details on the factors that cause the effect, or the independent factors. Why does it happen? And you can brainstorm. Each of the new idea statements now becomes a subject. It's kind of like a version of the 5 whys, and you can look at the cause below that as you go further and further down towards a root cause. Here we see a tree diagram with why is a hood rejected. We've broken it down into 2 major problem categories, assembly and finish. Assembly can be spot welds, which is spatter at strength, which could come down to heat settings, and now we see a relation between heat settings, spot welding, and spatter. So it is useful in looking at relationships of cause and effect. And as you can see, it's a variation somewhat of the fishbone diagram for cause and effect. Again, part of the engine behind it is the 5 whys. We're continuing to ask the cause of something to get down to a root level that is measurable and actionable. Covered again here under project management tools is the XY matrix, which is used anytime you need to help make a decision or prioritize items. It aids in deciding among several options. It can be used in the define phase, measure phase, control phase. It's a very useful tool throughout the phases. You list the options, decide on the criteria, measure against, and you score it in matrices we've discussed before. Under project management tools, you would want to also associate the variant of the matrix diagram, which is simply a non-numerical form of the XY matrix used to illustrate relationships. And you can do that simply by showing a visual relationship without giving it a quantitative number. Project management tool to help make decisions, understand associations, again, can be used in define, and certainly in voice of the customer and many other areas. A process decision program chart, or PDPC chart, is a project management tool. It's a tree diagram used to illustrate anticipated problems and list possible solutions. It's another form of force field analysis. It may be a dynamic living document, and you can keep it as the project proceeds. Of course, most of these management tools, that's true of most of them. You can use it before implementing a plan. It's good for shaking down and testing out a proposed future state. So you develop a tree diagram, proposed plan showing the objective, a second level of main activities, a third level of broadly defined tasks to accomplish the main activities. For each task on the third level, you brainstorm what could go wrong. You review the potential problems and eliminate any that are improbable or that you don't feel are that worrisome, that they're insignificant. And then you show on a fourth level the problems linked to the tasks. For each potential problem, you brainstorm possible countermeasures. They might be actions or changes to the plan that would prevent the problem, or actions to remedy it once it occurs or mitigate it. And then you show these countermeasures as a fifth level, outline clouds or jagged lines. To decide how practical each countermeasure is, use criteria such as cost or time or effort, and mark the impractical countermeasures with an X and the practical ones with an O for adoption. Here we see an example of a PDPC, chronic illness management program. What could go wrong with it? We have the levels, and then we have the countermeasures. So inappropriate goals. We thought that nurse guidance and approval and checklist of possible goals was option. Under backsliding, we decided that financial penalties was not an appropriate countermeasure to backsliding, which affects patient goal setting, which affects patient self-management, and could compromise the chronic illness management program. So there we see that we have several countermeasures that the team might consider putting in place to help the chronic illness management program be successful. We have the activity network diagram in project management tool set, similar to the PERT chart. It allows the team to form a realistic schedule by graphically showing total completion time, sequence, and critical step tasks. So it's an abridged version of the PERT chart. And we see here a graphical visual representation of the tasks and the days to completion. Now we're going to talk about, in the project management, the importance of the communication plan. Your communication plan should clearly convey the project vision, strategies, and benefits. One tool you have there is the charter. It will identify many of these issues here. The charter is an extremely important document. You want to always try to kick off the project with a kickoff meeting where the champion should thank everybody for being on the project and reiterate the objectives and the importance of the project. You have to have an update reporting system. You need to, as one way in Lean Six Sigma, gate reviews or total gate reviews, we'll cover that here. But you have to have updating, reporting, and feedback to the stakeholders, leadership, champion. And at the end of the project, you should have a celebration of project recognition and look to how you can replicate the project. The benefits of good communication are somewhat self-evident. Communication is probably the number one failure of projects, is poor communication. Good communication keeps things going. You have feedback. You get help, direction, clarification of goals. And again, poor communication is certainly necessary and maybe sufficient condition for project failure. Now, when you design an effective project communication plan, you're going to have to ask, who, what, where, when, and how shall I report? What are my target audiences I think I need to communicate with? Obviously, that's going to be stakeholders or some subset. What's the need for the communication? How will I tailor my presentations to each audience? When will I do my communications? How and where? And why am I going to do these communications? One of the basic rules for effective meetings is you first ask yourself, do I need this meeting? Why am I having this communication? How are you going to do it? Communications begin before the kickoff and extend throughout the entire project through project celebration and project replication. These are a list of what probably is a large list of ways to communicate on a project. Team meetings, emails, probably the core communication method. Face-to-face ad hoc meetings, large lectures, memos, presentations, videotapes, set of frequently asked questions, lunch and learns, the list goes on and on of ways to communicate. The point is a plan of communication. How are you going to use these methods? Why are you going to use them and when? With respect to Lean Six Sigma, one of the basic communication tools is toll gate reviews or gate reviews. On a high consequence project, you probably would want to have a toll gate review between every phase. Oftentimes, you do combine the improve and control phase report out, since implementation of improvements in control are so closely intertwined. But you basically have a review after each phase where the champion and the stakeholders can give comments and concerns or bless the project or decide if the project should be stopped or continue. These reviews keep the project on track, give you guidance, help you address issues in a timely manner. They should be performed by the project team. Use visualization to the maximum extent possible. Lean Six Sigma encourages visualization and graphs and saying things in pictures that as soon as the viewer sees it, he understands the point you're trying to make. Report outs usually should be reviewed with the champion prior to bringing it before all the stakeholders. Storyboards are often used to convey project information. It's a favorite form of conveying information in a Lean Six Sigma project. A3 documentation. A3 a language comes from the Toyota production system. A3 means that's a paper size. Toyota production system. Toyota wanted its managers and its employees to put all critical information for a given issue on one piece of paper, and it could be printed on 11 by 17. So that became the term for A3 documentation. It's the concept of putting everything you'd like to know about a particular issue on one piece of paper. So here we see some examples of A3 documentation. Here we have a defined phase on one piece of paper, start of a defined phase, measure phase, A3 summary of the measure phase, A3 summary of the analysis phase, A3 summary of the improvement, A3 summary of the control phase. So those would have made a story. The general form of A3, particularly with respect to short improvement events where you're going to summarize a short project on one piece of paper, is you have a plan section, a do section, and a check act. So something like this, you have a plan that summarizes what your plan was, what you did, and what you did to check and act. It could be either in the future tense or the past tense or somewhat of a living document. It need not be, the spirit of Lean is that it need not be computer generated, and Lean practitioners would entertain simple handwritten plans for, say, an order management kaizen to reduce order form error stops. You could just put down your history, your goals, your charter elements there. I highlighted your charter elements, and they show the current state map. They brainstormed and they chose some root cause solutions, and now they're in a state of control. So they put everything they wanted to communicate about the project on one piece of paper, and it wasn't fancy. That's the concept of A3, or storyboards are visual. Try to convey everything you want to know to the viewer visually in as short amount of space as necessary. Try to make it all value added. If done correctly, storyboards in A3 reduce volume and can help the user quickly identify what's trying to be told to him from the project team.